For decades, space travel was like building a luxury ship, sailing it once, then sinking it. Rockets were single-use, making access to space staggeringly expensive. But what if rockets could return, refuel, and fly again, just like airplanes? This is the promise of reusability, a revolution transforming our reach for the stars. By recovering and reusing the most expensive parts, especially the first-stage booster, we can slash launch costs and open space to more than just governments and megacorporations. Cheaper launches mean more satellites, more science, and more people living and working beyond Earth. Reusable rockets are the engine of the modern space race, turning space from an exclusive destination into a new frontier for all. Every booster that lands safely is a leap towards sustainable exploration and a future where humanity expands its horizons. This vision has sparked a global competition, with engineers worldwide racing to master the art of rocket recovery. The challenge is immense, like tossing a pencil over a skyscraper and having it land upright, but the rewards are even greater. In this high-stakes race, new players are emerging, eager to claim their place among the stars. December 3, 2025. Inner Mongolia's desert became the launchpad for a bold new chapter in spaceflight. Landspace, a private Chinese company, unveiled Zhuque-3, a stainless steel methane-fueled rocket built for reusability. As engines thundered to life, Zhuque-3 soared skyward, its ascent flawless. A powerful debut for China's commercial space sector. Stage separation was executed perfectly, sending the second stage and its payload toward orbit. Landspace joined an elite group, proving it could deliver assets to space. But the real test was just beginning. The first stage booster, instead of being discarded, was programmed for a controlled return. The world watched as the booster, now a silent projectile at the edge of space, prepared for its most daring maneuver yet. Landspace had already achieved a major victory by reaching orbit. Now, all eyes were on the challenge of bringing the booster safely home. After separation, the Zhuque-3 booster hurtled back toward Earth at hypersonic speeds, its first task flip engine first using thrusters, bracing for a fiery re-entry. 4 titanium grid fins deployed, steering the booster with precision as it battled searing heat and brutal forces. Onboard computers constantly adjusted the fins, guiding the rocket toward its landing zone in the Gobi Desert. The grid fins slowed the booster from hypersonic to supersonic, using the atmosphere as a brake. This delicate descent was a major test, one that Landspace's guidance system passed with flying colors. Approaching the ground, the booster was on target but still moving too fast for a safe landing. The final step: reignite the main engine for a landing burn, slowing the rocket for a gentle touchdown. Everything had gone right, until the very last moment. In the final seconds, the Zhuque-3 booster fired its engine for landing. For a moment, it seemed to work. A flame appeared, but the burn was unstable. A catastrophic malfunction in the propellant feed system caused a hard start, and the rocket exploded just meters from its target. Despite the fiery end, the mission was a triumph in many ways. Landspace's engineers gained invaluable data. The rocket's structure, ascent, stage separation, and re-entry all performed exceptionally. The only failure was the engine reignition for landing, a pinpointed weakness to fix. In rocketry, failure is often the best teacher. This test was a massive experiment, and the explosive finale provided the precise data needed for improvement. Landspace now knows exactly where to focus its efforts. The next attempt will be stronger, smarter, and even closer to success. In aerospace, every failure is a step toward mastery. Zhuque-3's explosion wasn't a setback, it was a rite of passage. SpaceX, the global pioneer, endured years of failed landings before perfecting reusability. Landspace's first try managed a flawless ascent, stage separation, and guided re-entry, an impressive debut. Their guidance system brought the booster to the correct spot, showing remarkable sophistication. Blue Origin, another key player, also faced setbacks before landing its New Glenn booster. Landing an orbital-class rocket is monumentally difficult for everyone. What sets Landspace apart is its rapid progress, moving from Zhuque-2's Methalox milestone to Zhuque-3's ambitious flight in just over 2 years. They're learning from global pioneers, adopting proven designs and technologies. Elon Musk himself noted, "It takes time to match Falcon 9's reliability, but Landspace's strong first attempt shows they're catching up fast." The race for reusable rockets is truly global, and Landspace is now a serious contender. Zhuque-3's flight marks a turning point for China's commercial space sector. Once dominated by state enterprises, China's space industry now thrives on private innovation and competition. Landspace's near success puts it ahead of domestic rivals and signals that Chinese private firms can build world-class rockets. Reusable rockets are essential for China's plans. Massive satellite constellations and frequent launches demand affordability. Zhuque-3, designed for up to 20 flights, is key to making these ambitions possible. This capability isn't just commercial, it's strategic, supporting telecommunications, Earth observation, and national security. Landspace aims to service the Tiangong space station, breaking the state monopoly on crew and cargo missions. A reliable, reusable rocket will boost the station's sustainability and China's space leadership. The government's push for commercial space is paying off, accelerating innovation and competition. Zhuque-3's test is a giant leap for China's vision of a future built on reusability and private enterprise. The fiery end of Zhuque-3's first flight is just the beginning. Landspace will analyze, redesign, and try again, armed with data and a proven design. The question isn't if they'll land a booster, but when. This relentless cycle of testing and improvement is the engine of the new space race. The global contest for reusable methane-fueled rockets is heating up. SpaceX, Blue Origin, Rocket Lab, and now Landspace. China's entry adds a powerful new dynamic, spurring innovation and driving down costs worldwide. Mastering reusability is key to China's grand ambitions: satellite constellations, lunar bases, and Mars missions. By fostering a commercial ecosystem, China is building a foundation for interplanetary exploration. Landspace's progress is integral to this vision. We're witnessing a new era, one defined by global competition, commercial drive, and the dream of making space accessible to all. The sky is no longer the limit, it's the destination.